In this section, we would like to discover the precise relationship between the rates of the increasing or decreasing of the two quantities. In the following example, I will explain this rate of the change. So we begin our discussion of such related rates by considering the familiar situation in which the two quantities are distance and the two rates are velocities. Change of the position is called the velocity. So let's look at that question. A 26 feet ladder is placed against a wall. Okay, so this is the length of the ladder. So this length is 26, okay? One of them is enough. This is 26 feet. If the top of the ladder is sliding down the wall at 2 feet per second, the top of the ladder, let's use the blue color, this is the top of the ladder, okay? So this slides down at 2 feet per second. So if this length is y, what is the this change? This is the change of the y with respect to time. So this is 2 feet per second. But it is decreasing. So because of this reason, this is minus 2. So the sign minus, the sign minus means it is decreasing. How we can understand it is decreasing? Because slides down, okay? So downside is the negative part, as you know from the Cartesian coordinate system. Upside is the positive part. At what rate is the bottom of the ladder moving away from the wall when the bottom of the ladder is 10 feet? Okay, so actually we try to calculate the this change. Let's use the different color. This change in that direction. This is change of the x. So we try to calculate dx over dt, which is per feet per second, but we don't know. But you can say it will be positive because it's increasing. Okay, because it go to the right direction. And when we try to calculate this value, when x is when the bottom of the ladder is 10 feet from the wall, yes. So when x is 10 feet. So when x is 10 feet, this is 10 feet, and we know this is 26 feet. We can calculate the y easily. So we will calculate dx over dt. So for such questions, first of all, you should indicate the given values. Okay, these are given information, and actually not just this one. Also, x equals 10 is the given information, and we would like to find. Our aim is to find the that value. So you should write the relation between the all variables. So the relation between the variable x and y by the Pythagoras theorem is, you can say that square of the x plus square of the y equals square of the y equals 26 feet. By the Pythagoras theorem, let's use the black one. By Pythagoras theorem, we can say that x squared plus y squared equals 26 squared. It's always correct, okay? Because the length of the ladder is constant. Maybe x and y can change, that's okay, but this relation always correct. So by differentiating this equation implicitly with respect to time, and when differentiating we will use the chain rule when we need, we will obtain 2x times dx over dt, we differentiate in terms of the t, plus 2y times dy over dt, which equals, right hand side is constant, so derivative of the constant term is 0. So we obtain this equation. So this equation is the related with the rates of the dx over t and dy over t. Okay, so this is a related rate relation. And this type of the problems are called related rate problems. So here we know dy over dt is -2. Our aim is to calculate dx over dt. And when we calculate dx over dt, when x equals 10, and when x equals 10, we can find the y value by using Pythagoras theorem again. So 10 squared plus y squared equals 25 squared. So from this equation, we can say that y is 24. You can verify. Actually, 26 is 2 times 13. X is 2 times 5. So this is 2 times 12. Okay, by the Pythagoras theorem again. So y is 24. So here y is 24. So from here you can calculate dx over dt easily. So as a result, dx over dt equals minus 4.8. On the other side, 4.8. So 4.8 feet per second. So this means when the ladder sliding down the wall at the 2 feet per second, the rate of the change of the bottom of the ladder is 4.8 feet per second. For this type of the question, I have a strategy for the related problems. Okay, first step, you should understand the problem. So how you can understand? By sketching. Okay, if it is possible, sketch a figure if helpful, if it is possible also. Okay, so this is the suggestion. For solving related rate problems. In the problem solving hour, I will solve some problem in the business and economy science. Okay, so second step is identify all relevant variables. In the first question, x and y are variables. Okay, including those whose rates are given and those whose rates are to be found. Okay, so identify, given, and to find the values. Okay, to be found. Okay, let's say maybe we can write here identify. And in the third step, express all given rates and the rates to be found as derivatives. Okay, so you should find the relation. Okay, so by differentiating the relation, express all given rates and the other rates. Okay, to be found the rates which will be or generally it will be rate in the to be found as derivative. Okay, these are the derivative. Let's write as derivative. derivatives. And the step 4, find an equation connected to the variable identifying in step 2. And differentiating this equation. So in this third step, I give the explanation altogether, okay? Maybe we can express the two parts. So here, this part can be mentioned later, okay? So find the equation first of all. Find not an equation, okay, between the variables. And in the fifth step, by differentiating, we will calculate this relation, okay? In the step 3, just we will express, okay, not the relation between the rates, okay, between the related rates. So here, by differentiating, let's write by differentiating implicitly the find the relation not maybe between, maybe there are more than the two variable, but among the variables, okay, between the all rates given at the rates to be found, okay. Of course, when using the implicit differentiation, you can use the chain rule, okay, when you need. And in the last step, solve for derivative that will be give the unknown rate, okay. So solve for the derivative that will give the unknown rate. So according to this explanation, our variable are x and y. If figure is given, but if it's not given from the question, you should sketch this figure. So your variable x and y, you should identify your variables in the figure, okay, if it is possible, and express the all given rates. So this is the given rates, and the rates to be found. So this is the rates to be found, okay. Then you should write the relation by the Pythagorean theorem or some similar triangle or some known idea. Sometimes relation can be given from the question. So, and by differentiating relation, you should find the equation which is include to all rates, okay, and the, of course, the variables. So by using the known values, according to your aim, you can calculate the needed value.